Welcome back. Problem 12-22. So statement is determine the elastic curve for the cantilevered W14 by 30 beam using the x coordinate. Specify the maximum slope and deflection. E is 29 into 10 to the power 3 ksi. So you can see this is a cantilever beam that is having fixed support at point A, and there is a uniformly increasing load of 3 kips per feet. Clear? So due to this loading, the beam will bend like this. So what we have to find is we have to find this maximum deflection V max, and we will find this slope which is theta max for this cantilever beam in term of x, and we have to also find the elastic curve equation for this cantilever beam. So let's start with the solution. So as we know that we have this equation which is ei into d square v over dx square is equal to m of x. So we do not have moment. So what we will do that is if you remove this fixed support, so definitely you will be having a vertical force which is, let's say, is represented as ra, and there will be a movement, counterclockwise movement, and this movement is ma. So we will find this movement by using equilibrium condition. Is first equilibrium condition is that sum of all forces along y direction must be equal to 0 and force upward is taken as positive. Now you can see one force is ra and other force is uniformly increasing load. So if you convert this uniformly increasing load into a point load, so what we will do is that you will have to multiply 1 over 2 into 3 multiply by 9, because this load is triangular, so area under this load will give you a point load, and area of triangle is 1 over 2 into its base which is 9 and height which is 3. So this will give you this point load, and this point load will be equal to 13.5. Now we have two forces, one is ra and other one is minus 13.5, which is downward. So I will write it minus because it is downward. Their sum must be equal to 0. So I will write ra minus 13.5 is equal to 0. So from here you will get ra is equal to 13.5 kip. Now we will find the moment about point A, which is the our external moment. So for that we will apply another equation, that's sum of all moment about point A is equal to 0 and taking the counterclockwise moment as positive. Okay, so as we have converted this uniformly increasing load into point load, so it will be lying at uh, L over 3. L is the total length which is 9. So 9 by 3 is 3 feet. And this remaining distance will be equal to 6 feet. Okay. Now we will apply equilibrium condition, sum of all moment about point A. Since this force is passing through point A, it is not producing any movement. So at point A we have a reaction moment which is MA. So I will write it plus MA, and the other moment that is due to this load which is 13.5 into perpendicular distance is 6, and that is clockwise, so it will be negative. So minus 13.5 into 6 is equal to 0. So from here you will get movement, external movement about point A is equal to 81 kip into feet. Now we have reaction moment and reaction force at point A. So what we will do is that we have been asked to find the equation of elastic curve for in term of x. So we will cut the beam along this any length of x, because x start from here to till 9 points. So we will cut the beam at any point and we will draw the free body diagram. So when you cut it, so this is point A where you have RA which is 13.5 kips, and you have a moment which is 81 kip into feet. This is kip, and this length where we have cut this beam is represented as x. Now you will have a shear force layer, which when you cut the beam you will having a shear force which is v of x, and you will have a moment, external moment, which is mx, and let this point is 1. Now you can see that we have a uniformly increasing load as well. So what will be the magnitude of this w over here? Since you can see that at this end this is 3 kips, so when you cut the beam over here, let's say this distance is x, so here the magnitude of load here will be equal to w, and it is acting at x of total length, so w into x by 9. Okay, so this w is 3, as this is 3, because this is w. So I will write here this magnitude will be equal to, I will write it w naught, and that will be equal to 3 into x by 9, which is equal to x by 3. Now when you convert this uniformly increasing load into a point load, so definitely this point load will be acting at total length over 3, which is this distance will be x by 3, and the magnitude of this load, I will write it over here, the magnitude of this load will be equal to 1 over 2 into x by 3 into total length is x, and that will be equal to x square over 6. Okay, so what we will do that we are interested to find out this mx, so we will apply equilibrium condition that sum of all movement about point 1 is equal to 0, and taking the counterclockwise movement as positive. So one movement is this 81 about this point 1, which is plus, the other one is uh, this movement which is mx, this is also positive. The third movement is due to this load into perpendicular distance is x, and this will be clockwise, so it will be negative. The fourth movement will be due to this load, which is x square over 6, and perpendicular distance will be x by 3. So I will write first one is this 81, I will choose another color, 81 plus the second one is this m of x, third one is 13.5 into x, which is producing clockwise, so it will be negative 13.5 into x, and the fourth one is also producing negative, and that is minus x square over 6, this point load into perpendicular distance x by 3. Okay, so we will be having their sum must be equal to 0. So when you solve this and simplify it, you will get this moment m of x will be equal to 13.5x minus 0.0556 x cube. Okay, this should be positive. Now you look at the here, this into perpendicular, this is producing counterclockwise, so it will be positive. So make this correction, this is positive, so here it will be negative. Minus 81, this will be the moment, and the unit will be in kips into feet. Now you have this moment, you can put it in the equation, which is ei into d square v over dx square is equal to m of x. So you can just put the value 13.5 minus 13.5x minus 0.0556 x cube minus 81, and that is ei into d square v over dx square. So integrate it once, integrate it, we will get ei into dv over dx, and that will be 13.5 x square over 2 minus 0.0556 x4 over 4 and minus 81x, and plus there is constant of integration which is c1. And when you solve this, you will get, simplify it, it will be 6.75 x square minus 0.01389 x power 4 minus 81x plus c1. This will be equal to ei into dv over dx. Let this is your equation number 1. Now again integrate it. Now integrate equation 1. So I will integrate it. When you integrate, you will get v ei into v is equal to 6.75 x cube over 3 minus 0.01389 x5 over 5 minus 81x square over 2 plus c1x, and there is another constant of integration which is c2. So when you solve it further or simplify it, you will get 2.25x cube minus 0.002778 x power 5 minus 40.5 x square plus c1x plus c2, and the unit will be kips into cubic feet. If you do not write the unit, there no issue, because you have to concentrate on other side of the problem as well. So at the end you can just put the value. Okay, this is cubic foot. Here you have the unit is kip into feet square. Now let this is your equation number 2. Now you can see that you have c1 and c2 which are unknown constant of integration, and you can find them by using boundary condition. So we will apply boundary condition. What are these boundary conditions? So let's check that. Now you can see the first boundary condition is that at x is equal to 0, we have slope which is dv over dx is equal to 0. I will show you. You can see that this is the beam, so due to this you have a deflection. So at this point x is equal to 0, you have slope which is dv over dx is also equal to 0. And the second boundary condition is at x is equal to 0, we have deflection v is equal to 0 at this point. So we will use this. So at x is equal to 0, dv over dx is equal to 0. Put it in equation 1. Why equation 1? Because you can see that equation 1 is of about slope. So when you put x is equal to 0, so here you can see this will be 0, this will 0, this will be 0, and dv over dx is 0. It means that c1 is also equal to 0. So when you put it, you will get c1 is equal to 0. Now we will put another boundary condition that at x is equal to 0, we have deflection is equal to 0. So you have to put it in equation number 2. So when you put it in equation number 2, so you can see this term will be 0, this will be 0, this will be 0, this will be 0, and v is also 0. So it means that c2 is also equal to 0. So c2 is equal to 0. Now we will put the values of c1 and c2 in equation 1 and 2. So what we will get is that we will get, if you put in equation from equation 1, when you put, you can see this is the equation number 1. So we will get ei into dv over dx is equal to 6.75 x square minus 0.1389 x power 4 minus 81 x, and c1 is equal to 0, so it will be this one. And dv over dx will be equal to 1 over ei into 6.75 x square minus 0.01389 x4 minus 81. So this is equation of slope. Now if you put c1 and c2 in equation number 2, so from equation 2 when you put it, so you will get, you have to put it in this equation, so and divide it by ei on both sides, so you will get v is equal to 1 over ei into 2.25 x cube minus 0.002778 x5 minus 40.5 x square. c1 is 0, so c1x will be 0 plus c2 is also 0. And this is equation of deflection or equation of elastic curve. So we have solved our first part, which is about determine the equation of elastic curve. Now we will move toward maximum slope and maximum deflection. So from here you can see that this beam will bend like this, so we will having a maximum deflection which is Vmax at x is equal to 9, and here we have maximum slope as well. So you have to put x is equal to 9 in equation for finding slope. I will write for finding maximum slope theta max, which is equal to dv over dx at x is equal to 9 feet. So you can just put x is equal to 9 in this equation. Okay. So in equation of slope. Okay. So when you put x is equal to 9, so it will be dv over dx is equal to 1 over ei into 6.75 into 9 square minus 0.01389 into 9 power 4 minus 81. And if you simplify it, this is at x is equal to 9, which is equal to maximum slope. So maximum slope will be equal to, after simplification, it will be minus 273.375 divided by ei, and the unit will be kips into feet square. Now e is given as 29 into 10 raised to power 3 ksi. We do not know I, so I, what will be the I for this W14 by 30? So that you have to go to appendix C of this book and you have to find the I. So let's move and we'll go to appendix C. Now you can see that at the end of book appendix C, so you have to go to W section. So here you can see this is W in 14 into 30, and the value of I is 291 inch power 4. So write down this value over here. So I is 291 inch power 4. Now put the value of EI and E and I in this maximum slope equation. So when you put it, sigma max will be equal to 2 minus 273.375 divided by 29 into 10 raised to power 3 multiply by 291, and you will calculate it. You will get sigma max will be equal to 0.00466 radian. It will be a negative, but if you do not write negative, if you write it negative, then it's okay. If you do not write negative, then you have to show that this slope is clockwise. I have shown it over here like this is clockwise. Now, this is the answer of our second part, maximum deflection slope. Now we'll find maximum deflection. So for maximum deflection, V max will be at x is equal to 9. So put it in equation of deflection. What is the equation of deflection? So you can see this is the equation of deflection. So I will put the value. So V max will be equal to, or at x is equal to 9 will be equal to 1 over EI into 2.259 cube minus 0.002778 power 5 minus 40.5 into 9 square. The unit will be kept into feet cube. Now you have EI as well, so you can just put the value of, when you solve it, you will get it as minus 1804.275 divided by EI. So you can just put the value minus 1804.275. E is 29 into 10 raised to power 3 and I is 291. So this will give you maximum deflection, and when you calculate it, you will get maximum deflection will be equal to okay. So this here the unit, you can see this is kept into feet, so you have to multiply 10 raised to power 3 as well. Okay, and you have to multiply 10 raised to power 3. Okay, 1804.275 into 10 raised to power kips. Here unit will be kept into cubic feet. So you have to convert this into inch, feet into inch, because this is inch power 4. So I will further simplify, minus 1804.275 into 12 cube. We will not this, we will remove this because you can see you have this 29 into 10 raised to power 3 ksi, so it will cancel that. Okay, divide by 29 into 10 raised to power 3 multiply by 291, and if you simplify it, you will get maximum deflection will come out to be minus 0.369 inch, or V maximum is equal to 0.369 inch, and deflection will be downward. So this is the answer. So here this equation is equation of elastic curve. We have maximum slope and we have maximum deflection, and this was all about problem 12-22. I hope you have enjoyed this video. Those who are new to my channel, then subscribe it and press the bell icon so that you can get notification about my latest video. If you have any question, you can ask me in comment section. Thank you for watching.